Hello and welcome to this Python tutorial. Alright, so let's take this challenge to reach this 86% accuracy, which is the relevant measure of the accuracy through k-fold cross-validation. And the solution to succeed, the best tool to use to accomplish this goal is parameter tuning. So what is parameter tuning? Okay, so as you noticed, in this first artificial neural network that we just built, we have two types of parameters. We have the parameters that are learned from the model during the training, and these are the weights. And we have some other parameters that stay fixed, and these parameters are called the hyperparameters. So for example, these hyperparameters are the number of epoch, the batch size, the optimizer, or the number of neurons in the layers. And when we trained our artificial neural network, well, we trained it with some fixed values of these hyperparameters. But maybe that by taking some other values, we would get to a better accuracy overall with k-fold cross-validation. And so that's what parameter tuning is all about. It consists of finding the best values of these hyperparameters, and we're going to do this with a technique called grid search that basically will test several combinations of these values and will eventually return the best selection, the best choice that leads to the best accuracy with k-fold cross-validation. Alright, so let's implement parameter tuning with grid search on our artificial neural network. So the good news is that it's actually quite the same as implementing k-fold cross-validation, because we will use the Keras classifier to wrap our artificial neural network in a classifier that can be used for scikit-learn, but instead of using the cross-val score function, we will use the grid search CV class, and so basically we'll create an object that we're going to call grid search of this class, and this is this object that will apply parameter tuning on our Keras classifier, that is our artificial neural network. So that's good news, because basically what we can do to implement this very efficiently is to take everything from here to the top, copy, and we're going to paste that here in the section tuning the ANN. And now, as I just explained, we will not use the cross-val score function, but we will use the grid search CV class. And same, we import this class from the model selection module. If by any chance model selection doesn't work for you, and that depends on the version you have, try to import it from scikit-learn.gridsearch module. That's actually the old name of the module to import grid search CV. But it's either grid search CV or model selection. Okay, and now we need to import sequential and dense to make our artificial neural network. And as I told you, now it's exactly the same. We use this build classifier function to build the architecture of our ANN. So that's what we do here. Nothing has to be changed so far. And then we wrap the whole architecture in this classifier using the Keras classifier class. But in this Keras classifier class, we will not input the batch size and number of epoch arguments, because that's the arguments we're going to tune. And the arguments we're going to tune will be put separately in the grid search object that we're going to create. So we have to remove these two arguments here, and we'll use them in the grid search object. Okay, and now that's when things start to change, because now we have to code the part that is related to grid search. So it's going to take about 10 lines, but no worries, that will be simple. So what do we need to start with? We need to start by creating a dictionary that will contain the hyperparameters that we want to optimize, that we want to find the best values. So let's create a variable for this dictionary that we're going to call parameters. And so parameters is going to be a dictionary. So a dictionary in Python is a structure of data that contains keys, that is identifiers, and some values for these keys. And there can be several values for each key. And so basically, each key is going to be the hyperparameter that we want to input, and the values of the keys are going to be the values that we want to try, that is to test for our artificial neural network. And then all these values for all the keys will be combined, and what grid search will do is it will train the artificial neural network using k-fold cross-validation to get a relevant accuracy with the different combinations of these values, and eventually in the end, it will return the best accuracy with the best selection of these values. So now what we have to do is to create this dictionary with all the combinations of the hyperparameters that we want to optimize. So how do we create a dictionary in Python? Well, that's very easy. We have to use some brackets, and inside these brackets we're going to input the keys, that is the hyperparameters, and their values that we want to test. Okay, so what would we like to optimize? Well, we have many hyperparameters in the architecture and the training of our ANN. So we can, for example, tune the batch size. We can try several batch sizes because one of them will lead us to a better accuracy. We can also tune the number of epoch. For that same reason, there is an optimal number of epoch, but we can also tune some hyperparameters in the architecture of the ANN, like the optimizer, and some other hyperparameters. So let's start with the batch size. We're going to input the batch size and different values of the batch size in the dictionary. So how do we do that? Well, we have to put the name of the hyperparameter we want to optimize in quotes, like this. And we put the exact same name as the one given in the model. That is, we input batch size. All right, so that's the key. And now we need to test several values for the batch size. So we add here a colon, and in square brackets, we input the values we want to test. So which one would you like to test? Well, we've seen in the previous tutorial that a batch size of 10 led us to a relevant accuracy of 83%, and we would like to beat 83%, so we will not test 10, but some other values of the batch size. Let's test two values of the batch size, and we're going to try 25 and 32. So why 25 and 32? Well, that's based on my experience, and that's also common practice to take powers of 2. Well, you can try other values of the batch size, but let's see what we get with these ones. Okay, so that's for the first parameter. Now, let's take care of the second hyperparameter. What is it going to be? Well, let's try to optimize the number of epoch. So same, we input the real name of the number of epoch parameter, that is NB epoch. So basically it has to be the same name as the one used to train the ANN. So NB underscore epoch. And here that's the same, a colon, and in square brackets, we input the values we want to test. So okay, let's try again with 100, but we won't get the same results as what we got here because we used a batch size of 10, and now we use a batch size of 25 and then 32. So let's try 100, and let's also try another value, like for example, 500. Maybe we won't reach convergence with 100, and maybe 500 will lead us to a better result. We never know. So okay, that's already two hyperparameters that we're tuning, and now I'm giving you a little challenge. What if we want to optimize a hyperparameter that is in the architecture here? For example, let's say we want to tune the optimizer. Well, what we would need to do is to add a third key here, and in quotes, we input the name of the hyperparameter, that is optimizer, and colon. But then, how do you input some different values, considering that we already have a value of the optimizer here? We didn't have values for the number of epoch and the batch size, so we can try several of them here. But here we already have a value for the optimizer, so how can we test some other ones? Well, there is something specific we have to do. We have to create a new parameter of the build classifier function, and this new argument is of course going to be an argument that will give us choice for the optimizer. So how does it work? Well, we're going to give a new name to this optimizer argument, and we're going to call it optimizer. And here, we're going to copy this and replace the Adam optimizer here by this optimizer argument that now plays the role of a variable. And so now we have the right to input different values that we want to test for our optimizer, because what will happen is that this key here will be associated to this optimizer. And so when we give different values for this key, well, the different values are going to be tested in this optimizer here. So that's the trick, and therefore, if you want to tune any hyperparameters that are in this architecture here, that is in the architecture of your ANN, well, what you have to do is to create a new argument for the hyperparameter you want to tune, and then replace the value here by the name of your argument. Okay, so let's try some different values of our optimizer. So still we use some square brackets, and inside the square brackets we're going to try several optimizers, and so of course we're going to try the Adam optimizer, and then let's try another one. Actually, another very good optimizer that is sometimes a better one for deep learning models is the Rms Prop Optimizer, which is another excellent optimizer based on stochastic gradient descent. Feel free to have a look at the Keras documentation to get more info, and you'll see, for example, that they recommend to use this RMS prop for recurrent neural networks. This is generally a better choice, and indeed this is the optimizer that we're going to use for recurrent neural networks. But let's still try it for our ANN. Maybe this will lead us to better results. Okay, so that's it for the parameters that we want to tune. That is, try to find the optimal values. And now what we have to do is, of course, to start to implement grid search. And so remember, we imported the grid search CV class. And so now you can guess what we're going to do. We're going to create an object of this class that will contain this parameters dictionary with all the hyperparameters that we want to tune and the different values that we want to test. And of course, this grid search object will contain our estimator, that is our classifier, and eventually it will also contain the information related to k-fold cross-validation, because remember, when we tune our model with grid search, well, k-fold cross-validation is going to be used to evaluate the accuracy. And so what we'll need to enter for grid search is a scoring metric, which is going to be the accuracy, and the number of folds in k-fold cross-validation. And of course, we will choose 10, like we did for k-fold cross-validation in the previous tutorial. So here we go. Let's create the grid search object that we're going to call grid search. And so this is an object from the grid search CV class. So I'm copying this and pasting it here. And now some parentheses. And inside the parentheses, we're going to input the parameters of the grid search CV class. So let's inspect the object. So as I just said, the first argument that we have to input is our estimator. And that's of course our classifier, which is our ANN. Then second argument is our parameters that we want to optimize, that we want to tune. And the name for this argument is param grid. And so for this param grid argument, we need to input our parameters dictionary that contains all the combinations that we want to try. And for each of these combinations, we will use k-fold cross-validation with a specific metric that is going to be the accuracy and a specific number of folds that is going to be 10 folds. And that's actually the last two arguments we need to input. That is the scoring metric that is given by the argument scoring. And so that is the accuracy. And finally, the number of folds, which is 10. So we close the parenthesis. And here we go. Our grid search object is ready. It contains all the information we need to apply grid search to our ANN. But now, as you can notice, this grid search object is not yet fitted to the training set. So that's exactly what we have to do now. We need to fit grid search to the training set. So to do this, that's exactly the same as what we used to do with the other objects. For example, when we fitted the standard scalar object to the training set, we need to take our object, grid search, then dot, then we use the fit method, and inside the fit method we input the training set. And the training set is composed of the matrix of features x train and the dependent variable vector y train. And actually this grid search.fit x train y train will create a new object, and so we will give the same name grid search to this new object. And so here I'm giving the same name grid search that will be fitted to the training set. Okay, so this will fit our ANN to the training set while running grid search to find the optimal hyperparameters that we are testing here. So we would already be ready to execute the code from now, but let's just add 2 lines of code to get what we're mostly interested in, that is the best selection of parameters and of course the best accuracy. So we're going to create 2 new variables that will contain these informations. So let's start with the best parameters. So here I'm creating a new variable and then best accuracy. All right. And now how can we get these best parameters and this best accuracy? Well, there is nothing more simple. Grid search is an object from the class grid search CV. And if you look at the info of the grid search CV class, you will see in the end that it contains some attributes. And one of them is best params that will get us exactly the best parameters. And another one is best score, which gives us the best accuracy that results from this best selection of hyperparameters. Okay, so let's get these 2 attributes. So to get an attribute from a class, we need to take the object, grid search, then dot, and then we just need to add the name of the attribute. So the attribute for best parameters is best underscore params, then underscore, and same for the attribute for the best accuracy. We take our object, grid search, then dot, and then we add the name of the attribute, which is best underscore score and underscore again. Alright, and with these two attributes we'll get the best selection of the hyperparameters that we're searching and the best accuracy resulting from this best selection. Okay, and now that's the most exciting part, because basically we don't have anything to do. Everything will be automated. Grid search will find the best selection of the hyperparameters for us. So you can totally do something else. You can have some lunch, have some dinner, have some fun, work on another project. You can even go to sleep. And actually that's what I'm about to do, because this will actually take quite some time, several hours maybe. That's why I'm recommending to do something else, because this is going to take some time. So feel free to do whatever you want, but in the end you'll get a much better result than this 83% accuracy. So let's set some goals with this accuracy. The absolute great goal would be 86%. Let's set this as the gold medal. Then another great goal, less hard to reach, would be 85%. And let's say that if we reach this goal, we have the silver medal. And let's say that if we reach 84%, we have the bronze medal. And before 84%, well, we are at the same level as in the previous tutorial, which remember was 83%, so we get no medal. Alright, so let's see what happens. I actually don't know what will happen because this is the first time I run this, so I will discover the results with you. And so just like you, I'm hoping to get at least one medal. Alright, so now we're going to execute the whole thing. So first we need to import the dataset and run the data preprocessing phase. So we're taking everything from here to the top. Here we go. Dataset well imported and well preprocessed. And now let's finally execute the last section, parameter tuning. We have the whole tuning ready. Now we don't have anything to do, so have fun, and here we go. Alright, this is running and this is going to take a while, so we'll let this run and we'll see each other back at the end of the tuning. So I'll see you soon. Alright, welcome back. I think this is about to end, according to my ETA. So we're about to know on which step of the podium we are. Remember, gold is 86%, silver is 85%, and bronze is 84%. So at least let's hope we get a medal. Alright, so almost over. We can see here that at the last round we are at 86%, so that's a good sign. But remember, that's only the accuracy of one round, and maybe that we won't get the same good accuracy over 10 rounds, and that's why we're computing the mean of 10 accuracies over 10 trained test folds, so that we get a relevant measure of the model's performance. Okay, and now this is about to end in 3 seconds. So 3, 2, 1, and here we go. It's over. We ended up with an accuracy of 86.26%. So that's the accuracy of the last round, but let's have a look at the real measure of the accuracy, which is contained in best accuracy here, and the medal we get is silver, because we got an accuracy of 85%. So congratulations! Sorry for those who were hoping for the gold medal, but don't worry. First of all, silver is a good achievement, and second of all, getting the gold medal is going to be the homework of this section. So that will be excellent for you because you'll get to practice with neural networks, because in order to reach the gold medal you will have several options. One of them is to change the architecture of your neural network. Another option is to do some more parameter tuning. And now to finish this tutorial, let's have a look at the best parameters that were selected by grid search. Here they are in best parameters, and the winners are a batch size of 25, a number of epoch of 500, and an Rms Prop Optimizer. And so it's with these parameters that we managed to get an 85% accuracy and the silver medal. And now it's your turn. Try to get the gold medal. Put me one step down on the podium. I'll work on getting the gold medal too, and as soon as I get it, I'll give you some hints and the solution. Until then, enjoy deep learning!